Question 12c. Use mathematical induction to prove that 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4 plus plus 1 over n times n plus 1 times n plus 2 is equal to 1 over 4 minus 1 over 2 times n plus 1 times n plus 2 for all integers n greater than or equal to 1. The first step is to show the statement is true for some value of n. And the smallest value of n that we can test is n equals 1. So we substitute n equals 1 into the right-hand side of the statement. Now the left-hand side of the statement is equal to 1 over 1 times 2 times 3, which equals 1 over 6. And the right-hand side of the statement is equal to 1 over 4 minus 1 over 2 times 1 plus 1 times 1 plus 2. And that equals 1 over 4 minus 1 over 2 times 3, which equals 1 over 6, which equals the left-hand side. Hence the statement is true for n equals 1. The next step is to assume the statement is true for n equals k, where k is some integer greater than or equal to 1. So that is 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4 plus plus 1 over k times k plus 1 times k plus 2 is equal to 1 over 4 minus 1 over 2 times k plus 1 times k plus 2. Next, we show the statement is true for n equals k plus 1. Now, this part of the statement, so the left-hand side, can be replaced with the right-hand side by the assumption. So 1 over 4 minus 1 over 2 times k plus 1 times k plus 2 is equal to the left-hand side. So what we need to do is take this side of the assumption and we're going to add on the next term, so the k plus 1 term. So we have 1 over 4 minus 1 over 2 times k plus 1 times k plus 2. That represents the left-hand side of the assumption, plus the next term along, which is 1 over k plus 1 times k plus 2 times k plus 3. I'll just make a statement here, so from the assumption. And that equals 1 over 4 minus k plus 3 over 2 times k plus 1 times k plus 2 times k plus 3 plus 2 over 2 times k plus 1 times k plus 2 times k plus 3. So adding these two fractions together by finding a common denominator, so multiplying this fraction here by k plus 3 over k plus 3, hence why we have a k plus 3 here and a k plus 3 there, and multiplying this fraction by 2 over 2. So we have two fractions now with a common denominator. So now we can add the numerators together. So that equals 1 over 4 minus k plus 1 over 2 times k plus 1 times k plus 2 times k plus 3. And the k plus 1 in the numerator cancels with the k plus 1 in the denominator here. And that equals 1 over 4 minus 1 over 2 times k plus 2 times k plus 3. And that equals 1 over 4 minus 1 over 2 times n plus 1 times n plus 2, since n equals k plus 1. So we can replace the k with n, and we end up with something that looks like the right-hand side of the original statement. So just made the point here, which is equal to the right-hand side of the original statement. So therefore, by the process of mathematical induction, the statement is true for all integers n greater than or equal to 1.